Hello, this is the AP Calculus BC 2019 problem number 10. The second derivative of function f is given by f double prime of x equals x times x minus 3 to the fifth times x minus 10 squared. At which of the following values of f does the graph of f have a point of inflection? So we're going to have to look at some of the properties of second derivatives. So if I go ahead and draw my graph, just some random graph, we'll see that the second derivative, when the second derivative is greater than 0, that means that the graph is going to be concave up. And when the second derivative is less than 0, it's going to be concave, you guessed it, down, which is what this over here looks like. And now, when the second derivative equals 0, that is a point of inflection. Now, I should clarify something. This is not necessarily true. It's when it goes from positive to 0 to negative. At the point when it's equal to 0, you have a point of inflection. You might be tempted or be tricked with something like this, where it's not true that the second derivative went from positive to negative, but that it's only 0 at some point, and that might lead you to an incorrect answer to a problem. So we need to find out for this graph, basically it's zeros. And well, we need to find out also when it goes from negative to positive. That's when it changes signs. And so if we just look at this, no matter what number we plug in for x in the x minus 10 squared part, that number is always going to be positive, no matter what. Because if I plug in a number bigger than 10, let's say I plug in 11, 11 minus 10 squared, that's 1 squared, that equals 1. And if I plug in a number less than 10, let's say 8, I still get a number that's positive. So for this squared function, this number is always going to be positive. But if we look at these ones with an odd power, or an odd exponent, they are going to actually be able to change signs. So, for example, x minus 3 to the fifth, when x is 4, we're going to have 4 minus 3 to the fifth, which is going to be 1 to the fifth, which is 1. And if I plug in a number less than 3, for example, 1, that's going to be negative 2 to the fifth. That is going to be negative 32. And as we can see, this changes signs. And so at x equals 3, that's when the signs change. Any value greater than x equals 3, it's going to be positive, and any value less than x equals 3, it's going to be negative. And then if we look up over here at the value of x, this is x to the first power, and at 0 again, it does change sign. If you plug in a positive value for x is going to be positive, and if you plug in a negative value for x is going to be negative. So we see that the second derivative will be 0 when any of these ones are 0. And this is 0 at the point 0, and this is 0 at the point 3. So the graph f has a point of inflection at both 0 and 3. So B is going to be your answer. Thank you much for watching, and goodbye.